Hello everyone. The next electrophilic substitution reaction of phenol is sulphonation. What is the meaning of sulphonation? You know, electrophilic substitution reaction of phenol will happen either on ortho and para position. So if hydrogen from ortho or para position are replaced by SO3H group, this we call sulphonic group. This process is known as sulphonation. SO3H group. The mechanism of the reaction I will not discuss in this video. In next video. In this video, I will discuss very important points regarding sulphonation. The topic is involved in 12th JEE NEET and BSc. Let's start. For sulphonation of the phenol, obviously a chemical is required. What is that chemical? This is our phenol. These two positions are ortho, this is meta, and this is para. For sulphonation, we need to treat phenol with concentrated sulfuric acid. Now, if you are bringing sulphonation at this temperature, 288 Kelvin to 298 Kelvin temperature, means at low temperature, this is low temperature, sulphonic group will be added mostly at ortho position. Means we are getting ortho substituted product as a major product at low temperature. If I talk about IUPAC naming, sulphonic will be the main functional group. Numbering will start from here, 1, 2. So the name will be 2-phenol sulphonic acid. Or you can call it orthophenol sulphonic acid. Same reaction means if sulphonation of a phenol you are carrying out at 373 Kelvin temperature, means at high temperature. In this condition, the sulphonic group will be added on para position. This will be your major product. IUPAC naming 1, 2, 3, 4, 4-phenol sulphonic acid or paraphenol sulphonic acid. Now this is the most important question here. At low temperature, why ortho substituted product is major, and at high temperature, why para substituted product is major? Let's try to find out the answer of this question. Very easily we can find the answer of this question. For this, I am going to draw ortho substituted product, this one. Now in this condition, when we have sulphonic group on ortho position, two factors are working. Number one, steric hindrance. As we all know what is the meaning of steric hindrance, or simply we can say repulsion. As you can check, sulphonic group is quite big group. 5 atoms are involved here, and these 5 atoms are very close to OH group. So obviously between these two groups, repulsion is there, which we call steric hindrance. So first factor which is working here as a steric hindrance, which will try to bring these molecules away from each other. Second factor is intramolecular hydrogen bond, or simply you can call it force of attraction. If repulsion is there, second opposite factor is there, attraction. How? Check. This hydrogen which is connected with this oxygen, as you know, oxygen is highly electronegative as compared to hydrogen. So these electrons are transferred toward oxygen. Now because this hydrogen is losing control on its electrons, so what charge will develop on it? partial positive. And here this oxygen is more electronegative than sulfur, so these electrons are going toward oxygen. Now 2 electrons of sulfur are slightly going toward oxygen, so this oxygen will carry partial -2 charge. Positive, negative, very close to each other, so they will have a force of attraction. This force of attraction is known as intramolecular hydrogen bonding. And this intramolecular hydrogen bonding is trying to bring these two molecules close to each other. So these are the two factors which are working. Now one is saying repulsion, one is saying attraction. Which factor will dominate? It depends on temperature. Simple. How? Look. At low temperature, like 288 to 298 Kelvin temperature, at low temperature, force of attraction will dominate. Means intramolecular hydrogen bonding will dominate. Force of attraction means intramolecular hydrogen bonding will dominate over steric hindrance. SH I will write, steric hindrance short. Definitely, if the temperature is very, very low, so the bonding will become strong. This attraction will become strong. That's why force of attraction is dominating over repulsion. That's why at low temperature, the ortho product is a major product. Please check, because that ortho product is getting stability or favorism due to intramolecular hydrogen bonding. Now as you will increase the temperature, suppose now we have increased the temperature at high temperature. At high temperature means like 373 Kelvin temperature. What will happen? As you will increase the temperature, the heat energy will be increased. This force of attraction will break. Means now in this case, steric hindrance will dominate over intramolecular hydrogen bonding. As steric hindrance will dominate, these molecules will repel each other. Due to repulsion, this sulfonic group will leave this position and it will occupy which position? Para position, where the repulsion will be minimum. So the molecule will be this. That's why at higher temperature, we are getting para substituted product as a major product. That's it. This is the reason. Very easy. Two factors are operating here. Force of attraction as an intramolecular force of attraction, intramolecular hydrogen bonding. Second, steric hindrance. At a low temperature, intramolecular force of attraction is dominating over steric hindrance. That's why ortho-substituted products are major. And at high temperature, steric hindrance will dominate over intramolecular force of attraction. That's why para-substituted products will be major. This is the reason. Very easy reason it was, but I want to talk the two words that book is using in this case, sulphonation. Those two words are kinetically controlled product and second is thermodynamically controlled product. These two words are written in sulphonation of phenol. First, we need to understand the meaning of these. When I am saying the product is kinetically controlled, what does it mean? It means if product is generated due to fast reaction. Then we will say the product is kinetically controlled. And what is the meaning of thermodynamically controlled? If product contains less energy in it, then we will say the product is thermodynamically controlled. What does it mean? Check. Please write down these two definitions. The product which is ortho substituted here means this one, orthophenol sulphonic acid. The book is saying this is kinetically controlled. Means at low temperature, kinetically controlled product is a major product. And para substituted product, the book is saying it is thermodynamically controlled. Product. Why? Let's try to find out the answer of this. For this, first you need the meaning of kinetically controlled and thermodynamically controlled. Please read it. At low temperature, as I said you, low temperature like 288 to 298 Kelvin. Steric hindrance is dominated by force of attraction, intramolecular force of attraction. So we will not consider steric hindrance here, just neglect it. Neglect it. No steric hindrance. At low temperature, just neglect steric hindrance. And after neglecting steric hindrance, give me the answer of this question. Actually, for convenience, I am writing SO3H. Actually, in reality, SO3 will attack on it, not SO3H. But for convenience, I am writing it. When I will solve the mechanism, here I will write SO3 as electrophile. Okay. One reaction is this. This is first reaction, means ortho attack. This I will call ortho attack. And we are getting ortho substituted product. And one reaction I am writing this one, para attack. So para substituted product will be generated, this one. Now because as I already said to you, steric hindrance we don't have to consider. So you will not answer according to steric hindrance. Nobody will say that here we have a steric hindrance, so that reaction will be slow and this reaction will be fast. As I said to you, at low temperature, steric hindrance we don't have to consider. Now, the question is, which reaction is fast? If steric hindrance we are not considering because the temperature is low, which reaction will be fast? Ortho attack or para attack? The answer is ortho attack will be fast. Reason. Dear students, here we have two ortho positions. And how many para positions we have? Only one. So which attack will be fast? This SO3 group, SO3H group, have two positions for attack. And here we have only one position for attack. Which reaction will be fast? Obviously, ortho attacked reaction will be fast. And again I am repeating, don't say steric hindrance will be here. We are dealing at 288 at 298 Kelvin temperature. Already I have said at this temperature steric hindrance will be dominated by intermolecular force of attraction. So we will not consider steric hindrance here. Cross it just. Forget steric hindrance at this temperature. Without steric hindrance, answer me that which attack will be fast here. So definitely the answer will be ortho attack, because two ortho positions are there and only one para position is there. So this reaction will be 2 times faster as compared to this reaction. So the product which is generated, what we will call it? Kinetically controlled. Please check the definition, meaning of kinetically controlled product. The product which we are getting due to fast reaction. Out of ortho attack and para attack at this temperature, ortho attack is fast. Reason? 2 ortho positions are there and here only 1 para position. So because the ortho attack is fast, so ortho substituted product we will call kinetically controlled product. This is the reason. Now, what is thermodynamically controlled? Check. For that, first you need to understand the meaning of thermodynamically controlled product. As I already said to you, the product which contains less energy in it, the product which contains less energy in it, that will be thermodynamically controlled product. Now, out of ortho substituted product and para substituted product which have less energy contained in it, which one? Let's check. At higher temperature, as you know, steric hindrance factor is dominating. We can't neglect it. At high temperature like 373 Kelvin temperature, steric hindrance factor is there, you can't neglect it. So if we have made this product at higher temperature, what will happen? Steric hindrance. Steric hindrance means repulsion. In 11th class and in lower class we have done that if there is a repulsion, the energy of the molecule will be increased. So this molecule will have high internal energy in it. High internal energy in it. Why? Because steric hindrance is there. Due to steric hindrance, repulsion is there. And repulsion will increase the energy of the molecule. But here, in para condition, repulsion problem will not be there because you can check the molecules are far away from each other. Steric hindrance is not there. So, if repulsion is not there, so this molecule will have less internal energy. And less internal energy means thermodynamically controlled product. That's why at high temperature, why we were getting at high temperature para as a main product, already I have discussed with you. Now why we are calling it thermodynamically controlled? Because this molecule contains less energy in it. Ortho contain more energy because steric hindrance is there, and steric hindrance means repulsion will increase the molecular energy. And here we don't have such problem, steric hindrance is not there. So this molecule will contain less energy. Less energy means thermodynamically controlled product. That's it. Now if I conclude everything in the sulphonation, phenol, when treated with concentrated sulfuric acid at 288 to 298 Kelvin, number 1, ortho substituted product will be the major product. Reason we know. Because intramolecular hydrogen bonding will dominates, which will bring these molecules always close. Steric hindrance will not be there. Steric hindrance is over dominated by intramolecular force of attraction. And this product which is generated here, we are calling it kinetically controlled. Means at low temperature, we are getting kinetically controlled product, which is orthophenol sulfonic acid. Reason we have discussed. And if we are bringing this reaction at high temperature, like 373 Kelvin, so firstly we will get para substituted product as a major product. Reason we know, because at this temperature stirring hindrance will dominate over hydrogen bonding. So the molecules will go away from each other, they will occupy para positions to each other. So this will be the major product. And this product, because it is less energetical molecule, para products are always less energetical as compared to ortho products. So because this molecule is less energetical, so we will call it, this is thermodynamically controlled. That's it. Means at higher temperature, the sulphonation will be thermodynamically controlled and the main product will be para substituted. At lower temperature, the reaction will be kinetically controlled and the main product will be ortho substituted. That's it. This is the end of the video. And in next video, I will tell you the mechanism of the reaction. Mechanism already we have discussed, but no problem. One more extra video for the mechanism of the sulfonation. Thank you very much for watching the video.